On question 7, and question 7 says, okay, so 7.1 says, at what annual percentage interest rate compounded quarterly should a lump sum be invested in order for it to double in 6 years? Okay, so be able to differentiate between when they're asking you for compound growth, future value, present value. So in this question, notice that they're just asking at what annual percentage interest rate compounded quarterly. So this interest is compounded quarterly. Should a lump sum be invested in order to double in 6 years? So there's an amount that you're going to invest and they want it to double in 6 years' time. And they want to know at what interest rate per annum compounded quarterly should this be. So these are the things that we know. First of all, this is neither present value nor future value because this is not speaking about payments being constantly made, the same payments being constantly made. It's one amount being invested and we want it to double after 6 years. So this is compound growth. And you know the formula for compound growth is just A is equal to P bracket 1 plus I to the power of N. Okay, so let's find out the things that we know here. First of all, they're asking at what annual percentage. So we definitely do not know the value of I. That's what we have to find out. And then secondly, they told us that something has to be invested and then it needs to double after 6 years. So in this case, this is where you're allowed to put your P value as anything, but the A value needs to be double of what the P value was. So you can use any number, it would still work out. So in this case, I'm just going to use let's say we were investing in 10 Rand. And so we know that it needs to double after 6 years. So our A value, the amount we get after would be 20. So you can also use that. And then the N, we have to find out what is N. So remember that they said they want it to double after 6 years. So we know that N is equal to 6, but it's also compounded quarterly. So we're going to say 6 multiplied by 4 to make it in quarters. And so N is going to be 24 quarters that we have. So we can go ahead and do this and we'll be able to find I. Also just remember your interest rate, whatever your interest rate is, it needs to be put over 4 because we're taking that interest and we're dividing it into 4 quarters. So we still also have to do that there. So we're saying A, which is the 20, is equal to your principal amount, which is 10, bracket 1 plus our interest is I over 4. And then this is raised to the power of 24 as N. Okay, so in order to solve for this, to find the value of I, because that's what we're just trying to do, to find the value of I, let's just get rid of 10 first. So we can divide both sides of this equation by 10. And so here, 20 divided by 10 is just going to be 2, is equal to, that would cancel. And we're left with just the 1 plus I over 4 raised to the power of 24. Then again, in order to get to the I, what is stopping us from getting to the I? So the first problem, the biggest problem would be the 24. So we need to get rid of the 24 by rooting both sides, the 24th root of both sides. So we're going to say 24th root over here and the 24th root. Okay, now to avoid writing long numbers, I'm going to just keep leaving this like that. So over here, this cancels. And then we're going to have still here the 24th root. I'm just going to keep calling it that. The 24th root of 2. And since that cancel, we just have 1 plus the I over 4. So we need to just take the 1 over. And so we have the 24th root of 2. And then we're just taking the 1 over. So it becomes a negative 1 is equal to I over 4. And then, of course, to get rid of the 4 so that we can solve for I, we're going to just multiply both sides of the equation by 4. So times 4 and times 4 over here. But I'm just going to put this like brackets and 4. So we put in the 4 over here so that it can multiply. Okay, so what will happen here is your 4's will cancel. And now you have that your interest is equal to, if you put that whole thing on the calculator, you'll find out what your interest is as a decimal. Okay, so we just get a 0.1172, and I just stick to 4 decimals. You can write the fifth decimal just in case it was going to round up. And in percentage form, you just have to multiply that by 100. So if we say take that and multiply it by 100, we just get an 11.72% as our interest. Okay, so that is the first question, 7.1. And now we're on question 7.2. So the information reads, Simon buys furniture to the value of 10,000 Rand. He borrows the money on the 1st of February 2020 from a financial institution that charges an interest rate of 9.5% per annum compounded monthly. He agrees to pay monthly installments of 450 Rand. The agreement of the loan allows him to pay equal monthly installments from the 1st of August 2020. Then 7.2.1 says, calculate the total amount owing to the financial institution on the 1st of July 2020. Okay, so let us just create a map of what's going on here. First of all, Simon borrows 10,000 Rand and he borrows this money on the 1st of February. So on the 1st of February 2020, notice that everything is in 2020, so I'm not really going to write the dates. So on the 1st of February 2020, he borrows 10,000 Rand. Then in the information, they say that the agreement of the loan allows him to pay equal monthly installments from the 1st of August. Okay, so let's see how far it is from 1st of February to the 1st of August. So we're just saying February, March, April, May, June, July, and August. So this is when he's going to start paying. But the question is asking you to just calculate the total amount owing to the financial institution on the 1st of July. So that is just a month before August. So on the 1st of July, that's when the present value is going to be determined. So I actually find this very helpful, the fact that they're already telling you how much is he going to owe on here. So you just have to really see, how does the money grow, because he already borrowed the money and you see that he's not paying for any of these months and he's only going to pay on the 1st of August. Now really how present value works is that when you borrow the money, you have to pay 1 month after. That's of course if your interest is being compounded monthly, then you have to pay 1 month after. So you see here, they're already telling you that you have to calculate how much is now going to owe on the 1st of July. And that's why I say they're actually making it easier for you, because you didn't have to think that through. So let's just see how the money is going to grow. Because this is a loan, it's going to keep gaining interest as long as it has not been paid for. So with loans, the interest is gained on what you owe. Okay, so how many months was this? From February. So February till May. So if we count it, that's just 1, 2, 3, 4, 5. On the 1st of July, you can see that the money is going to grow for 5 months. So we're just going to take this money and let it grow using compound interest growth formula. So that formula is A is equal to P bracket 1 plus I raised to the power of N. And so we have A is equal to the principal amount, the money that we want to grow is the 10,000 Rand. And we have 1 plus the interest being 9.5%. So we're saying 0.095 compounded monthly. So over 12, all raised to the power of. So remember, it is growing for 5 months. From here to here, it's growing for 5 months. So we're going to raise it all to 5 months. So all raised to the power of 5. Now you see, I'm not going to say 5 times 12. You only say times 12 when you're trying to convert the years into months. This is already in months. So let's go ahead and see what we get when we put this onto the calculator. And you see now that the money that he's going to owe on the 1st of July is going to be 10,402 Rand and 15 cents. That's how much he's going to owe. Then question 7.2.2 says, how many months will it take Simon to repay the loan? So now that we know how much he owes, and there's also other information that we actually know. We know how much he owes now. We know he owes this. We also know that he is going to be paying monthly installments of 450 Rand every month. And we also know the interest. So here we're going to be using the present value formula because we need to calculate how many months now he's going to take to pay them back. So remember, your present value formula looks like this. And let's just look for all the things we need to have. We need to find out how many months it's going to take him to pay them back. So we're looking for n. And these are the other things that we know. We know what the present value is. The present value is that 10,402 Rand and 15 cents that we calculated. The X is the monthly payments that he's going to be making, which they said was 450 Rand that he's going to be paying every month. We also know the interest. The interest is, of course, our 0.095 over 12. And so we need to just find n. Now, here's the thing about n. With n, I'm just going to leave n as it is. I'm not going to say times 12 because when you times it by 12, you're just trying to convert that number that you have into months. But they already told us to find out how many months it will take to repay this loan. So I'm not going to change that, and whatever I find as n will just be my months. If they asked you to convert it into years, that's a different case. Then whatever you get here being your months, you'd have to convert it into years. From months to years, you'd have to divide by 12. But they didn't ask us to convert it to years. They just asked for months. So I'm going to leave this as n, and whatever I get here will be the months. Okay, so now that we know all the amounts, we can go ahead and just put it all into this formula. So the present value, that is the 10,402.15, is equal to, your X is the 450, and then we open a bracket and we have 1 minus 1 plus our interest is the 0.095 over 12 raised to the power of negative n, which we have to find, close the big bracket, over the interest again 0.095 over 12. Okay, so something that you can start off with is this part. So you can just put this part as one fraction. So if we check on the calculator, what is 1 plus 0.095 over 12? You see that it's equal to this number. So in place of that, that's what I'm going to put here. Okay, so in that place, I'm just putting 2419 over 2400. Okay, so we have that. And now we can get calculating. So when calculating this, something you can do first is get rid of this. Get rid of this denominator out of this big fraction. And to get rid of that denominator, you're just going to have to multiply both sides by this. So I'm multiplying both sides by this. I'm saying multiply by 0.095 over 12. And I'm doing the same on this side. So I'm going to put brackets here, 0.095 over 12. So that is now gone. Then the next thing that is going to be a problem to get to negative n is this 450. So 450 is being multiplied by this bracket. We have to divide to get rid of it. So I'm saying divided by 450 on both sides. So divide by 450. And now this 450 is gone. All we have to do is actually calculate the value of this. And we can do this simply by saying we're going to put, first of all, a fraction for this whole big fraction. And then on the numerator, we'll first put this one over here, the 0 point, that fraction. So 0.095. Then I put over 12. And then you just go to the side, and in that, you're going to put brackets, and you put 10,402.15. And then on the denominator, we can put our 450. So 450. Okay, so we get a big number. We can just use it as a decimal instead. So that's easier. So we have 0.1830007, and it keeps on going. So I just do that to show I didn't round off yet. Is equal to, and we have now everything there's gone. We just have the 1 minus, open bracket, 2419 over 2400 to the power of negative n. Okay, so we're still looking for negative n. And first, the only thing we have to get rid of to get to the negative n is this 1. So we can take the 1 over. So this is where that aunt's button is going to be very important, you can use that. But on here, I don't have to use that. I'll just say is equal to. And since we're taking the 1 over, we're going to have to subtract 1 from this. So it's still this same number minus 1. And then, of course, we just have negative and this bracket raised to the negative n. So in this case, I'm just going to say it's equal to, and I'm saying minus a 1. So you see that answer minus 1. The number that we get here, I'll put it in decimal form instead. So we get a negative 0.81699, and it keeps on going. It's equal to this negative bracket again. Okay, and then in order to get to that negative n still, we're going to have to first get rid of this negative. So divide both sides or multiply both sides by negative 1. It will still work. So divide by negative 1. So in that case, I'm just going to say is equal to and then times negative 1. So I'll put it in decimal form. We have just a 0.81699 and keeps going. Now we have a positive of this. That negative is gone. And we have this 2419 over 2400 raised to the power of negative n. Okay, so the only way to find the value of an exponent that is your variable, so your n in this case, is to use log. So we're going to have to use log to find this. We're making negative n the subject. So negative n is equal to, and you're going to say log of your base. The base is just the number that is carrying the exponent. So in this case, it's this base. And that's why I like to turn this into a fraction, because I feel like it's just easier to use like this. And so that was the 2419 over 2400. And then over here, you're going to have that number, which you can use as ounce. It will be fine. If you just press AC and you put all of this in and you use that as ounce, it will still work out fine. So by 0.8169, keep going. And as you can see, if I put that in, so remember, don't use this log, use this log with the base of A. So I put the 2419, 2400, and then in place of that, I just put ounce because I know that the previous answer was recorded. So I put ounce, and then this is what we get. We get negative n is equal to negative 25.6315 and keeps going. But of course, to get rid of the negative, you can divide or multiply by negative 1. So I'll just times by negative 1 this time on both sides. And so now we know that if you, of course, times that by negative 1, you're just going to get a positive of that. So n is finally equal to 25.63, and if you round off to 2 decimals, it's just 25.63. Now this is where you have to decide. Go back to the question and find out what was the question exactly. The question was, how many months will it take Simon to repay the loan? Okay, so you need to give the full answer in months. In this case, you're going to have to think about it like this. Will it actually take him 25 months to pay off this loan? If you thought of that, no, it will not take him exactly 25 months to pay off the loan, because in 25 months, he's still going to be owing a little bit. That's why we still have the 0.63. Only after that 0.63 months, the loan will be paid off. But remember, you need to answer them in months. So instead of saying 25 months or 25.63 months, you can say n is finally equal to 26 months, because after 26 months, the loan will be paid off in full. Okay, and that's 7.2.2. Moving on to the next question. Then the next question, last question in this question 7 is 7.2.3 says, what is the balance of the loan immediately after Simon has made the 25th payment? Okay, so immediately after he has made the 25th payment, what is the balance of the loan? So something you need to understand about present value and when you're calculating the balance or how much a person still needs to pay after a certain amount of time is this. So I'll make a small example of this. Let's say somebody borrowed money and they had to pay it after, let's just use months to make this much more simple. So let's say they had to pay it after 10 months. So they owe money, they have to pay it within 10 months. If I want to calculate how much the person owes after 7 months, okay, I'm not going to use that negative n that I'm going to put, that value of n, it's not going to be 7. I cannot put 7. It's not future value, it's present value. When you want to find out how much a person needs to pay after a certain amount of time, you need to give them the amount of years they still have, or the amount of months they still have left to pay. That's what is going to be your N. So in this case, we're not going to put 7 months, because after 7 months he has been paying, and now how much does he owe after 7 months? We're not going to use 7, we're going to use 3, because he has 3 months to go. That's how you use this. So that's how you put N when we're trying to find out how much a person's balance is, or how much they still have to pay. You put the amount of months or years that they still have left to pay off the loan. So in this case that we're looking at, it took him, okay, so when we look at how long it actually took him, the exact amount of months it took him to pay off this loan was not 26. At 26 months, he's paying off even more than the loan already. It took him 25.63 months, exactly there. So we're looking at it like this. If it took him 25, let's say this is a 25.63, and it kept on going 1, 5, 1, and all of that, right? It took him that amount. We want to find out how much does he owe at the 25th month. So it's just like in the previous example where you had the 10 months and wanted to find out how much he owes after 7 months. You're going to have to say this 10 minus the 7, and that is 3 months. We're going to put N as 3 months. The same way here, you would do the same thing, because we need to put how many months you still have left to go. Here, we're also going to say this 25.6315 minus the 25. And of course, you're taking 25.63 minus the 25. It's just going to remove that whole number of 25, and you're going to be left with 0.6315, and that keeps going. That's what is going to be our N value. So something I like to do, I like to use the exact amount. So over here, I will take ounce and minus that by 25, because I want to find out what that 0.6315, I just want to use only that number. So I'm saying it's equal to, then I'm saying minus 25. So there's the 0.63. Okay, so we're going to use the present value formula. We're going to put everything in except for the present value, because that's what we want. We want to find out what is his present balance after 25 months. Okay, so remember the present value formula looks like this. And so this is what we're going to put. Present value, or finding out what that is. He is paying monthly installments of 450 Rand. And we have 1 minus 1 plus at an interest rate of 0.095 over 12 raised to the power of negative, and we are putting that amount in. So that ounce button is going to help you a lot there. So 0.6315, and it keeps on going. Or you could use that ounce for it. Okay, so then we're going to have over 0.095 over 12. And let's go ahead and see what the present value is. So on my calculator, it's a bit different. On yours, you could have just pressed the AC, put everything in, and in place of that, you could have put the word, that ounce over there, because it has recorded this number. So there is, it will probably also look something like this for you. So there's the negative ounce. Please don't forget to put it as negative, because N is always negative in present value. And so the present value that we get is this amount. So it is 282.3, and I'm just going to round off the 2 decimals, 36. Okay, so that is the exact amount that he is going to owe immediately after the 25 months. Okay, so that concludes it for question 7. Now we move on to question 8.